Let's go over the probability notes. First, we're going to go over some basic definitions. Random phenomenon or chance experiment. This is when we have an activity or situation in which there is uncertainty about which of two or more possible outcomes will result. For example, roll a dice. When I roll a dice, I do not know which outcome I will get on my dice. There is some uncertainty there. A trial. A trial is a single attempt at a chance experiment. For example, one single roll of my dice. Outcome. My outcome is the result of my trial. So for example, when I roll my dice, I could roll a 3. Sample space. The sample space is the set of all possible outcomes of a chance experiment. For example, the sample space for rolling a dice is 1, 2, 3, 4, 5, and 6, since the faces of the dice are those numbers. An event is any collection of outcomes from the sample space of a chance experiment. Events are usually represented by capital letters, like A, B, C, so on and so forth. For example, we could let event A be roll a 3, event B be roll an odd number, and event C be roll a 6 or a 4. Complement of event A is denoted with A in a superscript or A with an apostrophe. And this is all outcomes that are not in event A. So the complement event A is all outcomes not in that event. Event A or B. This is also known as a union and is denoted with A and a big U, B. It's all outcomes in event A or event B or both events. It's the union of two such events. Event A and B. This is known as the intersection of A and B. It's all outcomes that are in both events, the intersection of two events. Mutually exclusive or disjoint events. This is two events that have no outcomes in common. Example 1. Let event A be roll a 3, event B roll an odd number, and event C roll a 4 or a 6. Show the complement of A. The complement of A, first, we have our sample space, and A is roll a 3. So 3 is within my event A, which is that circle. My entire sample space has 1, 2, 4, 5, and 6 on the outside of event A, since they are not 3s. If I would like the complement of A, it would be everything outside of A. So that would be denoted by highlighting all of those values. So it would be all the space outside of that circle of event A. Example 2. Let event A be roll a 3, event B be roll an odd number, and event C be roll a 4 or 6. Show the event A or B. So first, I would show A and B together. Event A is 3. Event B is roll an odd number. So I have 1, 3, and 5 in B. 3 is in both A and B, since it's both odd and 3. To show this, I would need to highlight event A or event B or both, and that is shown there. Example 3. Let event A be roll a 3, event B be roll an odd number, and again, event C roll a 4 or 6. Show event A and B. So this would be a 3 and an odd number. So again, I have event A, B, and the rest of the sample space, 2, 4, and 6 being on the outside. 3 and an odd number would be the intersection, which would be the middle part where both A and B overlap. Example 4. Again, let event A be roll a 3, event B be roll an odd number, and event C roll a 4 or a 6. Show two disjoint events. So my two disjoint events, which means they have nothing in common, would be event B and C. B is an odd number, and C is a 4 or a 6. Those do not have anything in common, so they would not overlap. Lastly, the law of large numbers. The long-run relative frequency of repeated independent events settles down to the true relative frequency as the number of trials increases. For example, this figure shows the stabilization of the relative frequency of heads in a coin toss. So the probability or relative frequency of getting a heads is 1/2 or 50%. The more I roll or toss my coin, the closer it will get to 50%, the more coin tosses I do.